Hello everyone. For the rest of today's lecture, we are going to learn how to set x-axis and y-axis limits for a plot. Then we are going to have a discussion about logarithms. A lot of people find it really difficult to understand the concept of logarithms, including people in the STEM fields. So what we are going to do today is we are going to come up with an approximate definition for logarithms, which is not completely correct, but it is very easy to understand. It's really important to get a good sense of logarithms in order to be able to use logarithmic scales in plotting. Finally, we'll learn how to generate multiple plots within the same figure, and we are going to have a brief discussion about some of the examples in the plot design section of today's lecture reading. Let's first learn about setting axis limits. We are going to go back to the iris dataset. Recall that the iris dataset provides us information about iris flowers, including details like sepal length, petal width, and class. We have three different class of iris flowers. If we want to extract the unique names of each of those classes, we can easily do that by first of all extracting the class column as a series, and we can convert any series into a set just like we can convert any series into a list, and that will give us the unique values over here. Before we talk about axis range, I want us to extract part of the iris dataset which only contains the data about Iris virginica flower. Recall that we can do that by writing a Boolean expression. So I'm simply going to say df of class equal to Iris virginica. That will give me a Boolean series. I can reapply this Boolean series back to the original data frame, which is going to give me a subset of the original data frame where I only have rows which contain class as Iris virginica, correct? So I'm going to capture this sub data frame into a variable called sub underscore df, and let's take a peek at sub underscore df here. Recall that in the previous version of the analysis of this data set, I mentioned that this data set contains 150 rows. It has 50 rows for each class of iris flowers. So if I wanted to confirm that my sub underscore df here has the correct data, I can think of adding an assertion statement to check that the length of sub df is exactly 50, right? So I'm going to say assert len of sub underscore df equal to 50, and this will ensure that our code crashes here if something is wrong with sub underscore df here. What I want to do next is I want to do a quick recap of how to create a scatter plot for this Iris virginica subset of the data frame to compare the relationship between petal length and petal width attributes. Recall that whenever you have a data frame, you can simply say data frame dot plot dot scatter, and you'll have to say what is the x-axis column name and what is the y-axis column name. Since we want to compare petal length and petal width, it makes sense to have petal length as the y-axis column here, and the x-axis column is going to be petal width. Let's take a look at the scatter plot. Do you think we are able to get a good sense of the comparison between the two attributes of petal length and petal width over here with this current version of the plot? Not really, right? It's very difficult to make meaningful comparison between the petal width and petal length because the x-axis range of values is from 1 to 2.5, whereas the y-axis is from 4.5 to 7. Wouldn't it be nicer if we had the same axis ranges for both x-axis and y-axis? That's exactly what xlim and ylim parameter will enable us to do. The xlim and ylim parameters take two different types of arguments. The first one is when you pass a single value, that becomes a lower bound. And the second one is that when you pass a tuple of values, you pass lower bound as the first value and upper bound as the second value. I just want to quickly mention one thing over here. The previous version of the notebook template file, which is the version that I used while recording the first video lecture for this lecture, had a typo. It said upper bound here instead of lower bound. Just in case if you see that in your current template notebook version, please fix this. This should be lower bound. So let's go through examples for both of these argument types over here. I'm just going to copy paste this scatterplot line code, and let's first try a single value. I'm going to move the other arguments into the next line. I can just do that by hitting enter. That will work because I have the arguments inside a parenthesis. So I'm going to say xlim equal to 0 and ylim equal to 0, and let's take a look at the plot. Slightly better than before, correct? At least we are able to get some sense of how the petal width and petal length for Iris virginica flowers compare. Let's try and use the tuple values instead of saying a single argument for x limit. So when we pass a single argument, we are saying that value is the lower bound. When we pass a tuple, we are mentioning both lower bound and upper bound. Let me also capture the axis subplot object over here, which is going to be the return value. So I'm just going to say ax equal to the plot function call. I am going to define a tuple of values for xlim. I'm going to say 0, 6, and for ylim also I want to say 0, 6 because we want to have the same axis range over here, correct? What do you think is wrong with this above plot? Go ahead and pause the lecture video here and look at this plot really quickly here and write a comment in the comment section stating what do you think is wrong with this plot. If you look closely, you can see that a couple of data points are being cropped out, right? There might be more data points that are getting cropped out. If we have a couple of them, there could be even more data points above this. How can we find out what is the maximum value of the y-axis attribute, which is pet-len over here? Recall that petal length is coming from the data frame sub underscore df. So I can simply say sub underscore df of pt hyphen len, and I can take a max of that particular column simply by calling the max function, right? No wonder our data was getting cropped out. The max value is 6.9. What is weird with matplotlib is somehow they decided this is okay, that it's cropping part of the data while generating that plot. Unfortunately, we'll have to write our own assertion statements to make sure that this doesn't impact us in a negative way. So we are going to have to use 4 different assertion statements to verify that your lower bound and upper bound in your xlim and ylim arguments do not fall above or below the max or min value correspondingly over here. So I'm going to first start writing one of those assertion statements, and then we'll go through how to write all 4 of those here. Before I write the assertion statement, I just want to let you know that all of the set functions that we've been covering so far in the topic of plotting have a corresponding get function. The get function simply gets the current value of whatever attribute that you're interested in about that particular plot, correct? So let's say that I want to get the y limit associated with this particular plot. I can do that by simply saying ax.get underscore ylim, and that's going to return the y limit tuple here for me. So I am going to use the get ylim function in order to be able to write my assert statement over here. What do I want to assert? I want to assert that my max value in pet-len column is not greater than or equal to the upper bound value for ylim over here, right? So you always want your y-axis limits upper bound to be greater than the max value in your data frames column. So I'm simply going to say assert df underscore sub, and I want to be able to get petal length dot max, and then I just need to verify that that max is less than or equal to the ylim value, which I can get by saying ax dot get ylim. That will return a tuple here for me. So I need to get the second value of the tuple, right? So I'm going to say of 1. And now the code is going to throw an assertion error. We are still getting this plot because the plot is coming from line number 1, but line number 3 will make sure that the rest of the program over here will not run when you have this assertion error. So let's take this code and expand this for all 4 combinations over here. We wrote one assert statement which checks the max of the petal length column with the y limit upper bound. We need all 4 combinations, right? We need to check the min of petal length with the lower bound of y axis over here. So it would be nicer if we can just get this column name from the plot itself. There is an easy way to do that. I can simply say ax.get underscore y label. Just like we are able to set the y label using set underscore y label, we can use the get underscore y label to get the y label. So most of these are pretty intuitive. So I'm just going to copy paste this assert statement over here. I want to check that the min of the petal length column over here does not exceed the lower bound. So I'm going to change my condition to greater than or equal to, and then I'm going to say get ylim of 0, right, because we want the lower bound. And I'm going to copy these two assert lines over here, and I'm going to replace y with x. So I'm just going to say x label, and then instead of ylim I'm going to say xlim over here. And let's change the actual limit here to be 0,7 instead of 0,6, so that we'll get the correct plot over here. It should be sub underscore df, my bad. Let me fix that in the previous cell as well. Here is the downside for assert statement. So I incorrectly used a different variable name, so I didn't actually pay attention to the place where the assertion was happening. Right now it's giving the correct assertion error saying that the ylim value, the upper bound is lower than the max. Let me fix that. Right, looks like we have a proper graph here now. Right, I'll wrap up this video here. In the next video, we'll discuss about logarithmic scale.